Hello and welcome to PB Edu YouTube channel. Here we solve all your queries related to your school chemistry. So today we have a question related to states of matter from the grade class 11. Here the question says a mixture of oxygen and argon gases in a 6.60 liter flask. So we have a flask. We can take it as like this. This is a flask in which we have oxygen gas and we have argon gas. Both the gases are there, and the volume of the flask, we can say that it is 6.60. V is the volume, and there is the temperature is 28 degree Celsius. So 28 degree Celsius, we have to convert. Always we convert while calculating temperatures. It would be 301.15 Kelvin. To convert this, we have just added 273.15 to the degree Celsius temperature. The other information given is contains 1.90 gram of oxygen. So oxygen mass is 1.90 gram and the mass of argon is 7.03 gram. And the partial pressure of argon in the flask is asked in ATM and the total pressure in the flask is asked in ATM. So we have to calculate all of this. Here we know that mass is given. Mass for oxygen and mass for argon gas. So the molar masses used would be for oxygen, it is for one oxygen atom, it is 16. So 16 plus 16 for two atoms, it would be 32 gram per mole. And for argon, it is 40 gram per mole. So as we know, we have mass and molar mass. So we can calculate number of moles of oxygen first. So for oxygen, mass of oxygen divided by the number of moles formula is mass divided by molar mass or the atomic mass. So it is m of O2. So it is 1.90 gram divided by 32 gram per mole. So the units cancels out, gram and gram, and the answer would be 0.059375 mole. This is the number of moles of oxygen gas. And number of moles of argon. For that, we need to take mass of argon divided by molar mass or atomic mass of argon, that is equal to 7.03 gram, that is given, and molar atomic mass is 40 gram per mole. So the answer is 0.17575 moles. So we have both the number of moles. So if we have both the number of moles, we can say that the total number of moles, because it is an additive property, so the total number of moles total would be number of moles of oxygen gas and number of moles of argon gas. This would be 0.059375 plus 0.17575 moles, that is equal to number of total moles would be 0.235125. We are not rounding off because the final answer is not obtained yet. So number of moles or total moles are obtained. So if we use ideal gas equation here, ideal gas equation, because we need to calculate the total pressure, ideal gas equation, and we have total number of moles. So we can use ideal gas equation. PV is equal to nRT. We have to calculate total pressure. So we can use P is equal to nRT by V. Here we have for total number of moles. So number of moles we will use is T total. P total is equal to number of moles total. R is gas constant multiplied by temperature. So temperature we have calculated in Kelvin and volume total. We will put all the values. 0.235125 is the value of moles multiplied by R gas constant 0.0821 liter ATM per Kelvin per mole and multiplied by 301.15 Kelvin. That is the temperature, and divided by the total volume given is 6.60 liter. After calculating, we will get total pressure is equal to 0.881 ATM. That was one of the answers required, 0.881 ATM. So we have one of the answers. We will write it here. Total pressure is 0.881 ATM. Next is partial pressure of argon. So we will use the formula P of one of the component, that is argon here, is equal to mole fraction of argon multiplied by total pressure. So to use this formula, we need to calculate the mole fraction of argon. So on the right hand side, we will calculate this. For the mole fraction of argon, we need number of moles of argon on the numerator and total number of moles, that is number of moles of argon and number of moles of oxygen here in the denominator. So number of moles of argon we will use. Number of moles of argon is 0.17575 mole, and on the denominator it would also come 0.17575 mole plus number of moles of oxygen, that is 0.05937.5 mole. So here when we calculate this, it would be 0.17575 mole on the numerator, and on the denominator it would be the total number of moles, that is 0.235125. So when we calculate, we will get the argon 0.747. So the mole and mole units cancel out. So here we have the total pressure and the mole fraction of argon. So we can calculate partial pressure of argon here. It is 0.747 multiplied by 0.881 atm. So after calculating, we will get 0.658 atm. So the next answer required was partial pressure of argon, that is 0.658 atm. We will write it here, 0.658 atm. So we have both the answers. If you like this solution, want more solution like this for your queries, you can ask in comment section below. And for the solution videos, you have to subscribe to PBEdu YouTube channel, and don't forget to press on the bell icon so that you don't miss any video. Thank you.